Okay, so today we are going to be talking about shape of distributions and center and spread. So these are for quantitative displays. So shape is our distribution. You might remember hearing about this in Algebra 1. We talked about it a little bit. If you look at this first little dot plot, you can see that it has a cute little, bell shape. I'm trying not to do a hook at the side, but I keep messing it up. Okay, well, so we're going to call this bell. It's also symmetric. If you imagine a little line of symmetry down the middle, it would fold onto itself. So we call it symmetric. Now, in the future, there are some bell or symmetric distributions that would be called what we call normal, but normal is a very specific category of symmetric, so we can't necessarily say that this is normal yet. Okay. Anyone remember what this goofy little 2 camel hump one is called? Do you guys remember what the mode is? The mode is like the most repeated value, right? Do you see that this kind of has two modes. I mean, strictly speaking, that is the mode because it's highest, but the data is centered around 2 different spots. So we call this one bimodal. Bi meaning 2. Like you guys are all bipeds because you got 2 feet. All right. Check this one out. Here I have the lump where most of my data is concentrated. Okay, then my lump has a tail. Okay, so in my data lump are my most repeated value, my mode, right? My median, my middle number is probably somewhere in my data lump, right? But then I have this tail that is pulling my average this direction, in the negative direction. So this is called skewed left or negative skew. You guys remember that one? This is negative skew. Well, if this one's skewed left, what's this guy? That's right. Okay, this time the lump is on this side and the tail is pulling the average to the right. So this one is skewed right. All right, what is it called when, okay, don't police officers wear the same thing every day? What's their little outfit called? Uniform. So what do you think it's called when we have like the same thing all the time? Uniform. This is the most boring. Okay. So it's pretty easy to spot what those look like for dot plots. It's a little bit more exciting with a box and whisker plot. Because, well, let's just start with this one. You see how this one is kind of even on both sides? Okay, this one is probably symmetric. okay? And I'm saying probably because we do not know where in between these quartiles the values are landing. Okay, we could have a bunch of stuff here and then have a bunch of points here, and that's really not that symmetric. Does everybody see what I'm saying? We don't know where between these dividers the data is actually falling, so we're going to say symmetric, but also probably, because we can't say for sure. Not enough information. This is so you don't get in trouble with Mrs. Madsen later for saying stuff is symmetric when it's not, because you don't know for sure. All right, for the skew, it's a little bit easier to say whether something is skew or not. Now, do you guys remember about box and whisker plots that this number right here is the center? Actually, I'm going to label along this one because we've already talked about it. So this right here is the center. Okay, it's also known as the quartile 2, second quartile. This right here is called either, depending on who writes your textbook, the lower quartile or quartile 1, which kind of makes sense because it's on the lower end. If that one's the lower quartile, yeah, this one here is the upper quartile or quartile 3. So it goes first quartile, second quartile, third quartile. All right, down here on the end, you have your minimum, also known as your lower extreme. What do you think is on the other end? The max, you got it. Or the upper extreme. Okay, what do you remember about the median? Oh, the center is also called the median. Let's add that too. We already said the mode was the most repeated, right? The mean is the one that's the meanest to do. You have to add them all up, add up all the data, and divide by how many there are. It's where you find the average, right? The mean is the average. Okay, does anybody remember what the median is? It's the middle number, right? The median is the middle. So this is the middle value. So if the very middle value is the median, how much of the data is on this side of the median? 50%, right? How much is up here? 50%. Okay, now we're getting somewhere. Now, the lower quartile is, guess what? The middle of the bottom. So the median is chopping the whole data set in half, and the lower quartile chops the bottom in half. What's half of a half? A fourth, okay? And the upper quartile is chopping the top in half, right? So the quartiles, 1, 2, and 3, are chopping our data in 2/4. So that means that 25% of our data is here, 25% is here, here. You should be writing this down if you're not already. And then the last quarter is right here. Is this all coming back to you? Okay, so this is where it gets dicey, because regardless of how long the whisker is or how big this little box looks, they all still have just 25% of the data in them. So when I look at this, how much of my data is in between my quartile 2 and my quartile 3? 25%, how much is in here between quartile 1 and quartile 2? Okay, but doesn't that look like it should be more? Okay, so you kind of have to it's an optical illusion. You just kind of have to know that they're all 25% no matter how big they look. Everybody got it? Okay. All right, so this is 25%, this is 25%. Do you see that half of my data is lumped right there? So even though it looks like it's the smaller whisker and the smaller area of the box, that's actually because my data is more concentrated. Everybody see it? It's like when you think of all the people that are packed into New York City, they're in there packed like sardines. Out here, it's like Wyoming. It's big, but there's nobody out there. It's just tumbleweeds, right? Okay, that's obviously an exaggeration. Sorry to the people of the great state of Wyoming. We know that you're there and we appreciate you. All right, so if you would please draw your lump, draw your tail. What is this distribution? Correct. All right, what about this guy? It's basically the same thing, okay? It's just my lump is a little bit more like lump and tail, right? It's still skewed left. All right, what about these? These are both skewed right, the pair of them. Because all of these, they're each 25%, no matter how big or long they look, or small or short. Fair enough? Okay. All right. We talked about the parts of the 5-number summary in Algebra 1, but I don't know that we called it the 5-number summary. Here we have, okay, box and whisker plots use 5 elements to sort and describe data. I really should have put this right before what we just did. It would have helped a lot. So I will fix that for next year. The upper extreme, or the max, is the highest number in a data set. I'm having trouble spelling highest, so I'm just going to write largest. Now I'm having trouble writing largest. It's been a long day. Okay. The upper quartile, or Q3, is the middle of the top half of the data set. So that's this guy, Q3. Okay, here is our max. The median, or center, or Q2, is the middle number of our data set. Okay, half of our data is above, and another way to say half is 50% of our data is below it. So whether I say half or 50%, you will know that is the same thing. There is the median, quartile 2. The lower quartile, or Q3, this is the middle. Whoops, that's Q1. Thank you. The middle of the bottom half of the data set. And then our lower extreme or minimum is the smallest number in our data set. Okay, so one more reminder. We have 25% here, 25% here, here, and here. Okay. What? Yes, an outlier. Good. So we use a little asterisk to mark an outlier. Okay, now this is just for your understanding. The quartiles do not actually have to be elements in the data set. Why would that be? Don't flip yet. All right, let's say that you had one, two, three, four, five. Let's do 8. 5, 6, 7, 8. Okay, what is the median for this data set? What's my middle number? 4.5, right? Is that actually in my data? No. So my Q2 is 4.5, not in the data set. All right, now look at the low end of my data, my bottom half. What's the middle number for my bottom half? 2.5. So my Q1 is 2.5, which is also not in my data set, right? I'm sure you can see where this is about to go. What about for my top end? What's Q3? Good. Okay, so the quartiles can be in between values. So they separate our data. They do not necessarily have to be in the data, and you cannot be in a quartile, you can be at a quartile. You can't be in a fence. Fence is a divider. Got it? Okie dokie, let's flip now. All right, here are our ACT scores for a class of 15 Algebra 2 students. Woo-wee. We have to make a dot plot above the number line below. Okay, so we're going to go above. Okay, we're going to follow the calculator steps to find the 5-number summary, and then we're going to make a box plot below the number line. Oh, that was clever, Williams. Okay, forgot what I did. All right, so I have a 15. I have a 19. I have a 14. Another 15. I should probably mark them off as I go. Okay, I've got another 14, 17, 21, 14, 15, there's 16, and 25, ooh, and 15, and 12, and a 13. Okay, how did I do? This thing, yep. Yep, this needs a title. So this is going to be our ACT scores. For 15 students. Okay, now we are going to turn this information into a box plot using the 5-number summary that we can get from the calculator. So we are going to go and put all of this list into the calculator. So clear your memory. Second plus 712. Okay, which is our favorite button in our statistics unit? Stat. All right, I thought that was going to be an easy one. All right, if we want to edit a list, we have to go to edit. So we pick number 1. Now, I don't have like their score and their age, or their score and their income. I only have one variable. I just have their score. Okay, so I'm only going to use one list. This is some one variable data. Okay, so I'm going to put these in. 15, enter. 19, enter. You can also use your down arrow. 14, enter. 15, enter. I'll let you guys do it. Okay. Now, how many students was I supposed to have in this list? Okay, so does it make sense that my cursor is now expecting the 16th value in the empty? Okay, so that's a good way to quickly make sure that you have the right number. It doesn't guarantee that you didn't like accidentally skip one and do another one twice, but it's better than not checking at all. All right, so we now go back to our stat button, and we want to calculate some stuff. We've already done our editing. We're going to go to the calculate menu. Boop. Okay, we want to calculate statistics for one variable because that's all we've got. So I'm going to pick number 1 for my one variable stats. Okay, it tells me, we'll come back to this stuff later. This is telling me my average. The X with the angry little unibrow, that's our mean. Okay, the N here is telling me the number of elements in my list. It's another way to count them. If I arrow down, you can see that it's giving me my minimum, my first quartile, my median, my third quartile, and my max. Isn't that all the stuff that we need to make a box plot? Yeah. So that's our 5-number summary right there. The 5-number summary is the 5 numbers that tell us how to make the box plot. All right, so what is my minimum? 12. So that's where I'm going to put the end of my whisker. Okay, what's my max? That's going to be where I put my other end of my whisker. Okay, what was my median? 15. So my quartile 2 is going to go there. Okay, where's quartile 1? 14, right next to it. And quartile 3, 17. Okay, so the little quartiles are what make up the little rectangle. So here's Q1, Q2 is somewhere in the middle, and here's Q3. I did not do a good job of this, but we're going to fix it right now. Whenever you make these for me, would you please tell me what your quartiles are? You do not want me guessing if you're not a great artist. So this is Q1, and it's 14. Everybody see how I want it labeled? This is Q2, and it's 15. Q3, and it's 17. This is how we cover our butt in case the drawing is a little. That way you still get credit for it. Okay, talk to me about the shape of this data. Skewed right. Okay, here is our lump, right? And here's our tail. Okay. Really quick, before we move on, let's talk about the mean, median, and mode really fast. What was our mode? – 14 and 15. So the mode was 14 and 15. Okay, what was our median? 15. Okay, do you see that those are both solidly in the lump? Okay, what do you notice about the mean? The mean is this right here. The mean is the average. This is the one where we add them all up and divide by how many there are. The mean is almost 16. So that's kind of on the edge of the data lump. Does everybody see what I'm talking about? Do you see how the tail is pulling the mean higher than the other two measures of center, the mode and the median? Okay, that's what's happening. That tail is tugging on the mean because we have to include these higher values in the average. Yes?
What's the N or is this in the
That's the number of elements in the set. That's our 15 Algebra 2 student scores. Okay. Everybody happy that the median and the mode are in the lump and the mean is getting pulled toward the tail? Okay. Moving on. Without clearing your data, follow the calculator steps to make a box plot on your calculator screen and sketch it. Ooh, okay. Let's do this. All right, we're going to go to Stat and hit Edit. Do we hit Edit? Oh, we already did the first part of we already did the list of numbers. All right, we're going to skip to number 3. We're going to turn on Stat Plot number 1. All right. Where do you guys see Stat Plot? Look up at the top. Do you see it's right above y equals? Okay, how do I get to the little blue font above y equals? I have to hit the second button. So we're going to go second y equals. How do you think we're going to turn off or turn on stat plot 1? Yeah, maybe. Yeah. Okay, so I'm going to pick on. Enter. It's telling me to do box and whiskers down here. Oh, okay. We're doing a box plot, not a dot plot. Duh, I didn't read. Okay, we're gonna do a box plot with the calculator. Sorry, guys. All right, which one of these do you think looks like a box plot? It's one of these two, and we want the one with the outliers. Okay, so we're gonna go down to type, and we're gonna arrow over to this guy and pick him. All right, and then let's see what that looks like. Okay, what do you think our lowest x value should be? Yeah, maybe give it like 10 or 11 so that it's not on the very edge, but you got the idea. All right, what do you think our biggest x value should be? Yeah, 27 would be good. All right, let's see what happens when we hit graph. Oh, there we go. That's pretty cute. All right, let's draw it in the box. Go ahead and sketch it in there. Don't forget to label what window you're looking at. So this edge isn't 0. This edge we made what? 10? So it's going from 10 up to 27. Go ahead and draw that in there. Okay. Any other questions? Yeah. Okay, look at your basketball players. Will you go ahead and describe the shape, please? I'm not going to make it so you can't see it. I'm going to make it so you can still see, okay? So when you look at this dot plot, what is our shape here? Skewed left. All right, we're going to find the 5-number summary and the mean. So how am I going to find the 5-number summary for this? Well, I'm going to put all of these into my calculator. So I have someone using this part of my board, so I'm going to do it on here. Okay, so I'm going to go through the steps with you. Ready? Okay, you can clear your memory. Second plus 712. Okay, go to stat. Pick edit to edit your list. How many 63s do I have? What? I have 2 63s, so I'm going to do 63, enter, 63, enter again. Right, because it's in there twice. All right, then I have nothing, and then I've got a 69 and 2 70s. And then I got a 71. And now I'm going to be quiet so I don't mess you up. Okay, so I had my little cursor is now in the blank one on 18. It's a pretty good indicator that I counted correctly. All right, I go back to stat. I go to calculate. Which option do I pick if I want my one variable statistics? Number 1. Okay, so my mean is my little X with a bar over it. Okay, it is 71.235. Do you still need my picture? Okay, if I scroll down, I can see that my min is 63. Quartile 1 is 70. My median is 72. Quartile 3 is 73.5. And my max is 75. Okay, tell me please how the mean compares to the mode and the median. The mode being this guy. Yeah, why? Yes, the mean is less than the mode or median because the data is skewed left. Okay, so the tail is tugging on the mean and pulling it to the left. Okay, my median is 72. It's in my lump. My mode is 73. It's really in my lump. My mean is 71.235, which is right there. It's kind of on the edge of the lump, on the bottom edge of the lump. Any questions about how that works? Okay, how many outliers have we got? 2. If we removed the dots at 63 and they were no longer included in the dot plot, what would happen to our mean, median, and mode? Well, there's an easy way to find out. You can go to your calculator, go back to Stat, Edit, and you can delete the 63s. Yes? It's a setting on your calculator, and I've never seen it before, so I'm going to help you, but I can't use this time to do it. I'm really sorry. I will do my best, but I have no idea, and it could take me days. I don't know. I'm sorry. Okay, so I've deleted from my list my 63s. I go back to Stat, Calculate, and I do my one variable stats. Okay, my mean is now 72.3. It looks like repeating. My median is 73. My mode is still 74.
But the mode was 73.
Still 73. Sorry, it's my bad. Okay. What happened? Did my mode change?
No.
Did my median change?
Yes.
Yeah, but not a whole lot, right? Okay, what was the most significant change? Yes, because I got rid of the two lowest values in my average. Boy, and it's 2:15. Okay, thank you. Ryan, get to go to the front office. I don't know why they didn't tell me. Okay. So, guys, outliers and tails, they don't have a whole lot of impact on the median and mode. They have a bigger impact on the mean. I'm going to say that again because I don't feel like I had everybody's attention. The outliers, they do not have much impact on the median or the mode. The outliers have a bigger impact on the mean. Everybody okay with that? All right. Okay. We're going to label these cute little lumps. Okay, here we have a couple of different distributions for data. And you can imagine that like a histogram with like the little vertical bars like this. If you can imagine that they have like infinitely many bins so that the tops of the bars appear to form a curve. So you make the bins narrower, narrower, narrower until the width of the bin is like non-existent. Then you would have these smooth, pretty little curves. Okay? All right. We have one that's symmetric, that's the middle one, and then the other two are skewed. We're going to label each shape, and we're going to determine which vertical lines represent our mean, median, and mode. So the one in the middle is our symmetric. Okay, on this guy we have the lump here and the tail off to the right, so he's skewed right. And this one has the lump here and the tail to the left, so he's skewed left. Okay. When we have a symmetric distribution, our mean, median, and mode are all in the middle in about the same spot. All right, now on these other two, it gets a little bit more exciting. Our mode is our most repeated value. So our mode is always going to be at the peak, at the highest point. So that one's easy to find. So the highest point here is right there, so that makes this the mode. Okay, it's the most repeated. Most repeated value. All right, over here, the mode is this guy. Still the highest frequency value. Now, we saw in our notes that it is the mean that is the most affected by the tail or outliers. So if my data lump is here and my tail is pulling this way, the one that is most affected by that is the one that is farthest to the right, and that's him, this guy. This is X bar. Okay, making, last but not least, this one is our median, our middle value. Okay, on the other side, again, we have our lump. Okay, and then the tail is pulling our mean to the left. So the leftmost is this, which is our mean. And the one in between is our median. This is our middle value. Okay. So that's how I would do it. If you ever have to label these, I find the mode first, which is always the top of the peak. Okay, the mean is going to be the most affected by a tail or an outlier, so it will be pulled the farthest away from the mode, and then the median will be somewhere floating in the middle. Okay, generally speaking. Okay, measures of spread. This is an easy one. The range. The range tells us how far apart the extreme values are. This is the min and max. So to find the range, we are just going to do max minus min, big minus little, and that gives us the range. All right, the interquartile range that is the IQR, tells us how far apart Q1 and Q3 are. So the IQR is kind of like max minus min, except it's going to be Q3 minus Q1. So it's the upper quartile minus the lower quartile. Okay, the standard deviation is going to tell us how far, on average, the data points are from the mean. Okay, so the range tells us how far our max and min are apart. The IQR tells us how far apart our upper and lower quartiles are. The standard deviation tells us how far, on average, the data points are from the mean. Every single one of these measures is talking about how far, how far, how far. They're all measures of spread, okay? Our mean, median, and mode, these are measures of center. They're telling us what the middle of our data is doing. Okay, this is telling us how spread out our data is, how far apart things are. It's different. Okay, here in our tables we have the average ages of Academy Award winners for Best Actor and Best Actress for randomly selected decades from the 1920s to the 2010s. Okay, so these are averages for entire decades. Because they are randomly selected, this means that this is a sample, not an entire population. So if we're asking if we should use population or sample standard deviation, the answer is sample. Because it's random. Okay, now we are going to find the mean, median, range, IQR, and standard deviation for the best actors and the best actresses' ages to the nearest hundredth. All right, geez Louise, we can do it, it's fine. I do need my paper though. Okay, so I'm going to my calculator. I am going to clear and reset all of my memory because who knows what I have stored in here, because my algebras are also using these calculators. And I'm going to do second plus 712. All right, I'm going to stat, edit, and I'm putting in list 1 my average age for my best actors. So I've got 49, 42.8, 41, 45.5, 44.8, 47.4, and 43.3. Okay, just verifying that I have 7. 1, 2, 3, 4, 5, 6, 7. Good. Okay. So now I'm going to run my one variable stats for the actors. Stat, calculate. I'm going to pick number 1, one variable stats. I'm going to write these down so that I'm not going to be toggling back and forth the entire time. So for my mean, I have 44 point, let's do 3 decimal places, 829. The mean is that X with the angry unibrow. Okay, I have to arrow down to get my 5-number summary. It says my median is 44.8. My range, I just do max minus min. So 49 minus 41 is 8. (49 minus 41 is 8). Okay, my interquartile range, oof, I got 47.4. Minus, so I'm going to do Q3 minus Q1. So I'm doing 47.4 minus 42.8. I put an extra minus. I'm getting 4.6. Okay, standard deviation. Okay, at the top, ooh, all right, look at these. This is my sample standard deviation. Okay, and then this one is for population. Now, I do not have all of the ages for all of the best actors for all of the years. I have a random sample of the averages, so I'm going to be using the sample standard deviation, that is S sub x. So I will be writing down 2.756. Okay. Bear with me. Oh, good gravy. Okay. So I have forgotten my paper. 44.829. I have 44.8. 49 minus 41, which is 8. So this is the max minus the min. And then for my IQR, I'm doing quartile 3 minus quartile 1. And that gave me 4.6. And my standard deviation, because I'm doing sample, is S sub x. So that was 2.756. All right, now we have to do the same thing for the ladies. Ladies. All right, I'm going back to my calculator. Or not. Stat. Edit. I'm just going to copy the ladies over the top of these because they're the same length list. So I have 29, enter. Actually, I'm going to show you how to clear it. So you go all the way up to the top to list 1. Oops. And don't keep going, you gotta stop. List 1, you hit clear, and then you enter, and it clears your whole list. All right, 29, enter. 31.5, enter. 36.7, enter. 36.1, enter. 45.4, enter. 36.1, enter. I think I missed one. I missed 35.7 somehow. I'm going to add it. I missed the third from the last. I missed this one. Okay, sorry, mine are in a different order. You'll figure it out. Okay, so I go to stat, I go to calculate, and I go to one variable statistics. I'm going to hit enter a bunch of times. All right, and then I'm going to write down these values. So my mean is 35.786. My median is, arrow down, 36.1. Okay, my range is 45.4 minus 29. I'm getting 16.4. My interquartile range will be 36.7 minus 31.5. And I got 5.2. Standard deviation, I want the one for sample, that's S sub x. So that would be 5 point, let's talk about this. All right, I want it rounded to the thousandths place. So do I stay at 129 or do I go to 130? I go to 130 because the 7 tells me it's closer to 0.130 than 0.129. So it's 5.130. Okay, let me get this information copied into my table. Now, in this table, we have two different types of data. The mean and the median, and if we had the mode, we would include the mode. But these two are measures of center. They're telling us what the middle of the data is doing. Okay, the last three, the range, the IQR, and the standard deviation, these are measures of spread. So they're telling us how spread out our data is. Okay, so the bigger the value for my measure of spread, the farther apart my data is. Okay, so the first part C says to compare the mean and the median because those are both measures of center. Based on these two measures, what can we conclude about the data? So if I'm looking at the 44.829 and the 35.786 and then the 44.8 and the 36.1, these are bigger. So that means that on average, the best actors were older. Because the mean and median best actors are greater, we can conclude that the actors were older on average. I ran out of room. Okay, now we're going to look at the range, IQR, and standard deviation. So now we're not talking about center anymore. We are talking about spread. All right, so if I compare the 8 to the 16.4, the 4.6 and the 5.2, and the 2.756 and the 5.130, this time it's the ladies that have the bigger values. Okay, so because the range IQR and S sub x for best actress data are larger, the ages for the best actresses are more spread out we could also say / more variable. They vary more widely. Okay, so because the best actor ages have higher measures of central tendency, we can conclude that the best actors are older on average. Obviously, the women would be younger. Okay, and then looking at the measures of spread, we see that the best actress data is more spread out because it has higher measures of spread. So the best actress data is more spread out or more variable. And the men, the best actors, less so. Okay, I think that's the end. That's the end.